Welcome everyone. The question is in Young's double slit experiment, the path difference at a certain point on the screen between the two interfering waves is 1 by 8th of the wavelength. The ratio of the intensity at this point at the center of a bright fringe is close to 0.80, 0.74, 0.94 or 0.85. So in this particular question, you have to find out the ratio of the intensity between a point, the point at which the path difference between the two interfering waves is 1 by 8th of the wavelength and the center. So in this particular cases, if I consider this setup, which is a setup of the Young's double slit experiment, here basically S1 and S2 are nothing but the two coherent sources from which two waves are interfering with each other, but they are in same amplitude or and in same phase. When they just superpose on each other, then on the screen we are getting the bright and dark fringes like this. Okay, just try to understand that when one wave is just starting from this S1 and just reaches the point C, another wave is just starting from S2 and it also reaches the point C. The distance from S1 to C and S2 to C are same. That means S1C and S2C are same. That means there is no path difference between the two waves interfering with each other. That means we can say the intensity, which is the formula which is I at the point C, this can be written as IC equal to I1 plus of I2 plus of 2 root over of I1 I2, that is also under root over cos del. Okay, where here we have considered that I1 and I2 are the intensities of the wave coming out from S1 and S2. But since the amplitude and phase of the two interfering waves are same, that's why we can consider I1 and I2 are equal and just write it down I. So this is I plus of I plus of 2 I1 and I2 root over I1 into root over I2. Here it will be root over of I square. Okay, root over of I square. So root over of I square is nothing but comes as I simply. Okay, so I can write it down. It is simply 2I cos del. Now what is del? Del is nothing but the phase difference between the two interfering waves. The wave coming out from S1 and S2 when it is just merges on the point C. Actually it have no path difference. And the relation is that is the del, that is the phase difference equal to 2 pi divided by lambda multiplied by path difference. Since the path difference between the two interfering waves is 0, that's why the del is 0 for the point C. So I can just write it down in the place of cos del. In the place of cos del, I can write it down. This is nothing but 0. So cos 0 degree is obviously 1. So this will become I plus 2I. This will become 4I. So that is the intensity of the wave, intensity of the waves after interference. Okay, at the central bright, what is the intensity? That is the 4I. Clear? Next is at any point capital P, let us consider it is that particular point on which the waves are superposing obviously like this way, but here just try to understand that the path covered by the wave which is starting from S1 and path covered by the wave which is starting from S2 and just superposes on the point P, they are different. That means the S1P and S2P is different, and S2P is obviously it is greater than that of the S1P, and here in that particular case at the point P, that is the S2P minus S1P, it is lambda divided by 8 according to the question, which is the path difference on which point? At the point capital P. So just try to understand that in that particular point, if I want to find it out the intensity at the point capital P, then IP is equal to I1 plus of I2 plus of 2 root over of I1 root over of I2 multiplied by cos, and we have to find it out the value of the del at the point P, and that is be 2 pi divided by lambda multiplied by lambda divided by 8. Lambda cancels out. So this will become simply pi by 4. So it is I, same consideration, I1 and I2 are equal. It is I plus of 2 root over of I1 I2. This becomes simply root over of I square, and it becomes simply I, and cos pi by 4. Cos pi by 4. What is the value of the cos pi by 4? Cos pi by 4 is 1 by root 2. Cos pi by 4 is 1 by root 2. So it is basically I plus I is 2I, and I am just writing down it is 2I. Cos pi by 4 is 1 by root 2. So root 2 and 2 cancels out, it becomes simply root 2. So this will become 2 plus of root 2. 2 plus of root 2 multiplied by I. So now we have to find the ratio between these 2 points. That means the ratio of the intensity at the point P to that of the ratio of the intensity at the point C. That is the IP divided by IC. What is IP? IP is 2 plus of root 2 multiplied by capital I divided by 4I. Okay, it is 2 plus 1.414 multiplied by I divided by 4I. I and I cancels out. This will become 3.414 divided by 4. So if you do a little bit calculation, then this will become, it becomes 2. It becomes approximately 1.707. If you again divide it, this will become 0.85 or something. So obviously from here option D is the correct answer. Thank you all.